let's begin with question number 6 on this paper. Okay, let's move the question to a whiteboard, please. Okay, let's read and see. So they say that the curve y equals to 9 minus 6 over x and the line y plus x equals to 8 intersect at 2 points. So the first thing we need to find is the coordinates of the 2 points. Okay, let's do that part first. Okay, they give an equation of the curve and they ask for the intersection points. It is basically, that means because the intersection points lies on both curves, that means their x and y coordinates are related by these equations. So which means to say the y here and the y on this side are the same, and the x here and the x on this side are the same for those coordinates only because they intersect. That means we can solve this simultaneously to find the values. Okay, so that's equation 1 and 2. So let's put equation 1 into 2. So substituting is just like let's say y plus x equals to 8 into, so we copy that. And then the y part, I just replace it with what's given there from equation 1 in terms of x. The reason we do this each time is to get an equation entirely in x alone so that it is solvable. So we just rewrite this. Let's say, for example, x plus 9 minus 8 is 1, and then minus 6 over x equals to 0. Denominator has an x here. That means x is not 0. We multiply throughout by x. So each term changes. This becomes x squared, x times x. 1 times x is x, and this is minus 6 equals to 0. And then from here, we can factorize it. So it becomes x plus 3 and x minus 2 equals to 0, from which we get the two values of x as x plus 3 is 0, or the word is or because they're two different solutions. So x is negative 3, or x equals to 2. Okay, now we need to find the coordinates. That means even the y values. So let's just put back x equals to negative 3 or x equals to 2. Put back in which equation? Put back in equation 1. So we take the easy equation because it's readily in the format of y equals something. Or so y equals to 9 minus 6 over x. So the over x part means this is negative 3 and this is 2. So just to highlight that, I change the color. Okay, let's try to calculate both of these, please. So this becomes 9, negative is plus, 6 over 3 is 2. This is 9 minus 6 over 2 is 3. So y equals to 11 here and y equals to 6 here. So for the answer on this part, we take the x and the y here to get the first coordinate, which is negative 3, 11. Or the second intersection would be at when x equals to 2 along the branch, y equals to 6. So these are the two intersecting points, like intersections. Okay, now let's go for the second part, please. So the second part is talking about, hopefully we can do it here, the equation of the perpendicular bisector of the line joining the 2 points. Okay, let's think of the meaning first. What is this perpendicular bisector and all this kind of thing? Okay, let's just do a sketch first of the line segment containing the endpoints as the two given intersection points. So let's say it's negative 3, 11, and this is 2, 6. Okay, now what is termed as a perpendicular bisector is the line that goes through, is perpendicular. That's why the word perpendicular here. This one, the perpendicular bisector is speaking about this pink line. So the word bisector means it's in the middle. I mean, these two parts are equal. That means that means the point that lies on the perpendicular bisector, we need to calculate it as the midpoint. So since it's a midpoint, so let's think about the midpoint formula, please. So the midpoint formula is just like this is x1, y1, and this we call x2, y2. So it's just like the average of the x coordinates, and then followed by the average of the y coordinates. Okay, let's substitute and calculate that. So negative 3 plus 2 over 2, 11 plus 6 over 2. So this becomes negative 1 over 2, and this is 17 over 2. Okay, so this is how we calculate the midpoint, or the point which lies on the perpendicular bisector. Okay, for the second part, we just take a closer look at the word perpendicular. So the word perpendicular tells me that the gradient of the two lines, let's say This gradient we call it as M1, and this gradient we call it as M2. So the theorem goes that tangent theorem. Okay, the perpendicular bisector is M1 times M2 is -1. Oh, okay, M1 times M2 is -1. The M1 part, we can calculate it further using the formula of the y2 minus y1 over x2 minus x1. And then this is M2 times M2 equals to -1. So I'm just straight away writing it so that it's a bit easier to see. Okay, so the y2, and then all that, we just substitute as per the values there. So y2 is 6 minus 11 over 2 minus bracket minus 3. Please don't miss that. So it's a common mistake sometimes. So this is -5 in the numerator, but the denominator is purely just 5. Please take note of that trick. Huh? So this is -1 like that. This is negative M2 is -1, from which we can get the gradient now, or the M, is just 1. Okay, so now we know the gradient is 1. So let's think about the equation of the line, which is generally y equals to mx plus c. So y equals to x plus c when the m is equals to 1. Okay, now at this point, we want to substitute the value of a point on the curve into here. So the value of x, so this we take as x. So x is -1/2. And the y, we take it as 17/2. So this is 17/2 equals to -1/2 plus c. So solving this, we would get the value of c, which would be 17 plus 1 over 2, 18/2. C is 9. So after getting the c is 9, now we're ready to write the equation of the perpendicular bisector. Please take note, we must use this point, the midpoint here, not any other point, because this is the point which lies on the perpendicular bisector, not the other 2 points which are outside, the given points. Okay, now let's finally substitute either in here or here, and you should get the value, the final equation of the line as y equals to x plus 9. Thank you.